Hello, welcome to this class. Today we will be discussing some parts of the physics unit 0625 from the IGCSE syllabus, discussing the space unit, in specific the Earth and the solar system. Alright, let's start. First, let's talk about the Sun and the planets existing in our solar system. So we need to know that the Sun is the center of our solar system, and this is due its huge mass, and it takes up to 99% of the mass of the solar system. Alright, there are some planets that orbit the Sun. We're gonna name them in a short while, and our planet, the Earth, is one of those planets that orbit the Sun. There are some other dwarf planets that used to orbit the Sun, but we don't consider them anymore because they don't have high enough gravitational energy to stay in orbit. Okay, moving on. Let's talk about the planets that exist in our solar system. Currently we have 8 planets, namely starting from the order closest to the Sun: Mercury, then Venus, then Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The most important planet that we focus on is our planet, the Earth planet. So let's talk about the orbit of Earth around the Sun. So Earth is a rocky planet, and it rotates around the Sun in a circular orbit, which means that it completes one revolution around the Sun during one orbit, which takes around 365 days. There's another thing we need to discuss when we talk about Earth, which is the Earth axis. Okay, so there is an Earth axis, and the axis is tilted at an angle of approximately 23.4 degrees from the vertical. So if we look at the north, you can see that the axis is tilted 23.4 degrees from the north. And the Earth also completes one full rotation around its own axis approximately every 24 hours or every day. This rotation creates the daily motion of sun rising and sun setting, and we can call it the periodic cycle of the Earth rotation around its own axis. So the part that is facing the Sun, or the half of the Earth that is facing the Sun, will be having the day cycle, so it's nearer to the Sun. And then when the Earth complete a rotation, the other side of the Earth will be facing the Sun, and then this cycle can repeat to have day and night, or create the day and night cycle. Another thing we need to talk about is the Earth orbit. So as we said that the Earth is orbiting the Sun at the same time as it's rotating around its own axis. So the Earth orbit takes approximately 365 days, or as we know it as 1 year. And the combination of the Earth orbiting around the Sun and also the Earth rotation around its own axis and the tilt of the axis creates the season that we know, the 4 seasons. So now let's talk about the seasons. There are 4 seasons, as we know, and we will discuss them in terms of the relative position of the Earth from the Sun. So let's talk about position 1 and 2 first. So in position 1, the Earth is the north hemisphere of the Earth, which is the top part that is highlighted here with red, is closer to the Sun. So it means that the Earth is kind of tilting towards the Sun from the northern hemisphere, which indicates that we are in the summer season for the northern part of the Earth, the top half, where we have the longest time for the day and shortest for the night. Yeah. And then if we talk about the second position, position number 2, where the northern hemisphere, which is also the top part of the Earth here, you can call it the northern hemisphere, is facing away from the Sun, which is the furthest point away from the Sun if you look from this angle. Then we know that we are currently in this position at the winter season, where the day is short and we expect to have more colder days and less summer feeling. Yeah. And now if you take the mid positions where the Earth is centered on position 3 and 4, which are we call them the equinoxes, where the Earth is between the Sun at the northern and the south hemisphere at an equal distance from the Sun, which split the day and night into equal times, exactly equal times in both hemispheres. So in the equinox, as I said, we have equal day and night cycle, which means that it's split exactly into 12 hours, yeah. And then we can discuss in the northern hemisphere, we will expect the sunrise to be always coming from the east and the sunset to be always coming from the west, even during summer and winter. Now let's talk about the moon lastly, and the relationship between the moon and the Earth. So we know that the moon is orbiting the Earth, orbits the Earth around the axis of the Earth, yes, and then at the same time it travels around, or the moon itself rotates around its own axis. So the moon has a revolution around Earth which happens every 27 to 28 days, and the moon also completes one full rotation around its own axis, which happens in the same amount of time, 27 to 28 days, which means that the time taken for completing one rotation is equal to the time taken to complete one revolution. And this is called synchronous rotation. And that is due to the tidal locking between the moon and the Earth. So the Earth slows down the rotation of the moon, where we only get to see one half of the moon at all times, since they are tidal locked between them, yeah. So we always get to see the same side of the moon, which is gonna be facing the Earth throughout the whole revolution and the rotation of the moon. And then this appearance of the moon will change depending on its relative position from the Sun. So in this GIF animation, you can see that the moon, when it's approaching the Sun covers one side of the moon with the sunlight, and then the other side is dark, which is being observed from the Earth. So as it's rotating, we see different phases of the moon, or a periodic cycle of the moon, which we call it the different phases of the moon, or moon phases.